Friday classes, right?
Yeah, tomorrow is, even though it's Wednesday, it's gonna be a Friday schedule. Yeah. Also, just so y'all know, for tutoring, right? So like if you have classes on Friday, you come in tomorrow. But if you don't, then you straight, your vacation start today, you know? Um, just so you know, tutoring is gonna be open tomorrow, only from 12 to 6, because that's how we are open on Fridays. So plan ahead, if you guys want to do it online, cool, just 12 to 6. You want to do it in person, 12 to 6. All right. Mhm. On the third, yeah, yeah. Hold on, let me. Yes, we have class on the third, yeah, yeah, in person here. The break is only these couple of days. So Thursday, Friday, Saturday, Sunday. That's it. And then we back at it on Monday. You Um, before we jump into our new topic, any questions anybody has? You might want to go over anything. No, I didn't get it back yet. I didn't finish grading yet. But I'll definitely have that for y'all on Monday. If y'all want, I'm in tutoring on Monday from 12 to 8. Y'all could come in person and then just, I just give it to you right there if you want to do that. You guys can even do the test corrections in person right there. As soon as you get it back, just. Yeah. Yeah, come through. Yeah, for makeup test, just just come through, make an appointment to see me, and then just come in and I'll give it to you right there. If you want to come in and review a little bit before this, that's fine too. Yeah. Yeah. For the second test is like look at the review sheet. When you go into the announcements, there's a review sheet. Yeah, yeah. Then the final. Yeah, yeah. But it'll be good though. I promise you. I got y'all. Like not only are you gonna review here, there's the review class. If you guys can go through it, like you guys are gonna be in good hands. You know? So any questions? Or are we good? The cheat sheet, and then there's another one right underneath it. It's in the announcements. Like it's not the last announcement, it might be the announcement before that. Just like kind of scroll down and look at the announcements and you'll see. Yeah. Yeah. It's like an exam two practice or whatever. Just check that out. But it's not bad though. It's doable. I guess if nobody got questions, is this glaring too much, or you guys can see the board all right? It's good. You can see the board all right, man. In the back, you see it? All right. Let's take a look then. Since there's no questions, we're just going to jump into it. All right. But before we do that, real quick, I want to do a little blast from the past, right? So you remember when you have a question like this, right? I want to multiply x minus 3 times 2x plus 5, right? Well, how we do this again? What will we do? Exactly, right? We're gonna foil this, right? Let me get a different color real quick. All right, let's try it again. Yeah, 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 yeah. I got you. And anytime that happens, come through the tutoring. Like we can go over the last couple of questions that's mad hard. But yeah, so yeah, so just come through. So look, so we got x times 2x, right? It's gonna give me what? 2x squared, right? Then after that, I'm gonna do the next one, x times 5, right? Just make sure. Okay, good. X times 5, that's gonna give me a positive 5x. Then after that, I want to do the negative 3 times the 2x, which is going to give me a negative 6x, right? And then finally, I'm going to have the negative 3 times 5, which is going to give me a negative 15. After that, what do we do? Right. Which is another word for add, right? So we have the 2x squared, right? 5x minus 6x is going to be a negative x, and then minus 15, right? You don't have to. If you want to, go ahead, but you don't have to. And that's it. So you remember this, right? Nothing new here. All right. I have another blast from the past question real quick before we jump into today's topic. It's kind of from like last time a little bit, right? So we're gonna rationalize the denominator.
This is what I got.
I got you. So let's take a look, right? I want to rationalize the denominator. So I have square root of 5 over square root of 5 minus square root of 3, right? So I have to multiply this by the conjugate, right? To get rid of it, right? What's the conjugate, right? That's another word for opposite, right? So on the bottom, I'm looking strictly at the bottom, right? Looking strictly at the bottom. I have square root of 5 minus square root of 3. Opposite of that is going to be square root of 5 plus the square root of 3. Just like that. Right. And you want it to match the bottom, right? Be the opposite of the bottom. But what you do to the bottom, yeah, to the top, right? So same thing. So square root 5 plus square root 3, just like that. And then after that, you remember how we multiply the fractions, right? Just go straight across, right? Straight across. For the top, you know what I'm gonna do? I'm gonna distribute that, right? Square root 5 times square root 5. That's just gonna give me plain old 5, right? Next, I'm gonna do square root 5 times square root 3. Hold on a second. I don't know why 3 disappeared on me like that. All right. So square root of 5 times the square root of 3 is gonna give me, or positive times a positive. Is a positive, square root 5 times square root 3, this is square root 15. All right? So you remember how we multiply these radicals, right? Numbers with numbers, radicals with radicals, right? So anytime I multiply them and they can't come, you're just gonna put them on the other side, next to each other. I meant to say next to each other. On the bottom now. Square root 5 times square root 5, we know it's just plain old 5.
How do we do 5?
How is it? I got you. So look, square root 5 times square root 5 becomes square root 25. And square root 25 is just 5. Yeah. So now I'm on square root 5 times positive square root 3. That's going to give me a positive square root 15. Right?
Why you want to turn that? Oh, because it's not right.
Yeah. Now I'm going to have negative square root 3 times positive square root 5 is going to give me a negative square root 15. And last but not least, I have a negative square root 3 times a positive square root 3. That's going to give me a negative 3. It's negative square root 9, and you know the square root of 9 is 3. It's like that, right? Now what I want to do, I want to combine like terms, right? We're going to combine like terms. So long story short, in the middle, this is canceling out, right? Because that's positive square root 15 minus square root 15, right? Just cancels out. So now what do I have left? Let me change up my color real quick. So right, I have 5 plus square root 15 over 5 minus 3. Put that together, I have 5 plus square root 15, sorry, over 2.
That's it.
And that's it. That's my answer. All right. Questions on this? Go ahead, go ahead. Also being recorded, so can always rewatch it back. No problem. All right, we're gonna be doing the same kind of thing today, but we gotta build up to it a little bit. We gotta build up to it a little bit, right? So we're gonna take this to another level real quick. And then we're gonna get back to doing this. All right. So here where we going? So I want to evaluate the square root of a negative number. That's where we're going with this, right? Whenever we have a situation where we have a square root of a negative number, we say there is no real number that equals that square root. For example, to simplify the square root of -1, we are looking for a real number x so that x squared is equal to -1, right? Since all real numbers squared are positive numbers, there is no real number that equals -1 when squared. Mathematicians have often expanded their number systems as needed. They added 0 to the counting numbers to get the whole numbers. When they needed negative balances, they added negative numbers to get the integers, right? When they needed the idea of parts of a whole, they added fractions to get rational numbers, right? So adding the irrational numbers allowed for numbers such as the square root of 5, right? All of these together gave us the real numbers, and so far in our study of mathematics, that has been sufficient. But now, right, we will expand the real numbers to include the square root of negative numbers. So we start by defining the imaginary unit I as the number whose square is -1, right? So anytime you hear in math, oh, this is like I is an imaginary number. I is the square root of -1, right?
Yeah, I'll put somebody to like that.
Yeah. I feel like somebody needs to hear that again. So let's do it again, right? So the imaginary unit, right? The imaginary unit I is the number whose square is -1. So I squared is equal to -1, or I is equal to the square root of -1. All right, that's where we're going with this.
Good idea, mixing numbers and letters.
Yeah, that's how algebra came about, you know. When you go into like your field and everything, those letters are gonna become names, right? And then yeah, like a full name, and then you just have to know what you're doing with the name.
So you break it down.
Yeah, yeah. Like low key, if you have like say you have like a gram, and you know a gram is worth like $20, right? So you take the gram times the 20, that's how you know how much the bag costs. You know, like I mean, low key, like that's where that kind of idea, that kind of math came from, is from this kind of stuff, you know. So the square root of a negative number. So if b is a positive real number, then the square root of -b is equal to the square root of b times I, right? So low key, what's happening here? Let me just write this real quick so y'all can see. What's happening here is I'm kind of breaking this down into square root b times square root of -1. If you think about it, right? And then the square root b is staying the same, but the square root of -1 is becoming the I. Right?
There's an I, it's automatically a square root of -1.
Yes. Right. So what I'm trying to say is if I ask you a question, what is the square root of negative blah blah blah, right? The answer is it's square root blah 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 times I. That's what that's saying there. Right. Or you don't have to put the times I, just when you put it next to each other, that's good enough. Yeah. Yeah. So real quick. So we will use this definition in the next example. Be careful that it is clear that the I is not under the radical. All right. Sometimes you will see it written as the square root of -b is equal to I times the square root of b. That's how I write it. I write my i's in front of my radical, right? Because of this error, right? To emphasize that I is not under the radical. But the square root of -b equal to the square root of b times I is considered the standard form, right? So me personally, I like to put my i's in front of the radical. Right? Right. Let me give y'all an example of what I'm talking about real quick. Let me give y'all an example. So check this out, right? This says write each expression in terms of I and simplify if possible, right? So we already know what A is, right? A is just I'm gonna break down square root of negative 25 into what? This is gonna be square root 25 and square root of negative 1, right? What's the square root of 25? 5, right? So that's 5. And what's the square root of negative 1? I. So that's my answer right there, 5i. And it's that simple, you know? But let's say that I have an issue like a B, right? I'm gonna change this up real quick. Hold up. I don't want that. Let me get this. I gotta change my color up a little bit, right? So for B, I got the square root of negative 7, right? So here's my issues. Negative 7 can't get broken down, right? So I'm just gonna flip this into square root of 7 times square root of negative 1. Now we know square root of 7, that's just staying the same, right? Right? There's no perfect square that goes into that. But square root of negative 1 is I. Now, me personally, I like to put my I in front. Just like this. So I square root 7. That's how I like to do it. Yeah. You can say the same thing too. Yeah. It doesn't because it's computer, you know. But for like, if you like writing to me on the test or something, it's probably better to put the I in front just to make sure it doesn't get confused, it being under the radical, you know. Let's talk about like C now, right? I'm gonna change up my color real quick. So for C, right? I got the square root of negative 12, right? So we already know the same game we're playing, right? This is going to be square root of 12. This is going to be square root of negative 1. And square root of 12, you already know that's going to get broken down. That's square root 4 and square root 3, right? So what's going on? So we got what? This is going to be I. You already know. This is going to be 2. So I'm put it all together. My answer is going to be 2i square root 3, just like that. The square root of 4 is 2, right? So that's why the 2 is in front. Yeah.
Okay.
Yeah. So 2i square root 3.
Why you didn't just
Why didn't do
like 3
it?
times 4, right? Wow, so why you didn't
Exactly.
just do 3? Because now you did.
Well, yeah, that's what the square root 3 is. So the 3 can't get broken down because there's no perfect square that goes into 3. But square root of 4 is a perfect square. So that's how that gets.
Trying to avoid like making it.
Yeah. I'm trying to simplify it. That's what I'm doing. Yeah. But what I'm like showing you right now is that when you have a negative number and you have to write down that I, put the I in front. That's what I'm trying to say. All right. I'm gonna let y'all try some real quick. Nothing crazy.
They're both 5, right?
Yeah, exactly. I'm gonna let y'all try some real quick. Nothing crazy. Simple numbers. You know? Try that out. Yeah, the homework was posted for this section already. Y'all can take a look at that at the end of class or whatever. It's real simple. It's not nothing crazy, man. What's happening is like this is the new topic for the day. And then after we get through this, is just mixing what we did with the radicals before with this idea. And then we're off to the races. You know, it's the same thing all over again. So that means we're gonna do what? We're gonna add them, we're gonna subtract them, we're gonna multiply them, we're gonna divide them, and of course, in this situation, we're simplifying them. And that's it.
Right, right. And,
Give me an example. What do you mean?
no, no,
Okay. All right, let's take a look. Let's take a look, right? So I got the square root of negative 81, right? So we know the square root of 81 is 9, right? So my answer for A is just very simply 9i. I because of the negative 81, right? How about the B?
They go with the square,
You could, yeah, yeah, yeah. I was kind of skipping steps in case like you did that already, you know? What about B? I like that. I square root of 5. That's perfect, right? All right, that's a little bit harder now. What about C? 3i square root of 2. That's perfect. That was well done. Any questions on this? Anybody? All right. So that's it right there. Let's keep it moving. Let's keep it moving. I'm gonna take it up a notch just a little bit. So now that we're familiar with the imaginary number I, we can expand the real numbers to include imaginary numbers. The complex number system includes the real numbers and the imaginary numbers. A complex number is of the form a plus bi, where a and b are real numbers. We call a the real part and b the imaginary part, right? Let me just show y'all that again though, because this a little bit something extra. Here, let's see. So complex numbers. So this is a complex number right here. Anytime you hear people talk about complex number, this is what they're talking about. All right. So a complex number is of the form a plus bi, where the a, all right, and the b are real numbers, right? And the I is the imaginary part. So a plus bi, right? That's a complex number. Mhm. So a complex number is in standard form when it's written as a plus bi, where a and b are real numbers. If b is equal to 0, right, then the complex number a plus bi becomes a plus 0i, where a is just a real number. If b does not equal 0, however, right, then the a plus bi is an imaginary number, right? If a equals 0, right, then a plus bi becomes 0 plus bi, where bi is called a pure imaginary number, right? Just giving y'all some vocabulary, right? So that, you know, when y'all go out into the world, y'all be able to talk about this stuff, right? Not gonna quiz y'all on the vocabulary, but I'm just giving it to y'all. Yeah. But real quick, I think that this is still a little confusing. I just want to clarify it a little bit. Let me say it again in a different way, if that's okay. So when I have a plus bi, right? If b is equal to 0, that means that it's going to be a plus 0 times I, where it's just a, and that's a real number. A is a real number, right? If b does not equal 0, right? B is some other number other than 0, and I have a plus bi, that's an imaginary number. That's a complex number, a plus bi, right? If a equals 0, then you're going to have 0 plus bi, which is just the bi, and that's called a pure imaginary number right there. All right. So I hope that chart helps a little bit. All right, once again, so the standard form of a complex number is a plus bi. So this explains why the preferred form is the square root of negative b is equal to the square root of bi when the b is greater than 0, right? But you can always put your I before. If it was me, I put my I before. Let's put this all together one last time. So I have complex numbers, right? A plus bi. Your real number is going to be a plus bi when b is equal to 0. Your imaginary number is going to be the a plus bi where b does not equal 0. Put them together and you have what's called a complex number, a plus bi. Right? Just building the vocabulary a little bit. But we gonna get into this. All right. Good. So this is what we're trying to do now, right? Nothing that we haven't done before, right? So I want to add or subtract complex numbers. That's the goal here, right? So we are now ready to perform the operations of addition, subtraction, multiplication, and division on the complex numbers, just as we did with the real numbers, right? So adding and subtracting complex numbers is much like adding and subtracting like terms. We add or subtract the real parts and then add or subtract the imaginary parts, right? So our final result should be in its standard form. All right, let's take a look. Let's take a look. So real numbers with real numbers, imaginary numbers with imaginary numbers. Final answer is a complex number. All right, let's take a look. I'm gonna give you an example real quick. Let's take a look at this, right? So I want to add the square root of negative 12 plus the square root of negative 27, right? Let's simplify this down. You already know square root of negative 12. What's that going to be? That's going to be square root negative 4. Whoops, I didn't mean to do that. Square root 3. Let's call that what? 2i square root 3. Square root of negative 27, what's that going to be? That's going to be square root of 9, negative 9, excuse me, square root of 3, right? With a plus. I like to do that, yeah, because that's where I like to put my I with the perfect square, right? And square root of 3, boom. Now remember, same rules as before. I got the same index. I got the same radicand. That's the number that's inside of the radical, right? Because they're the same, I can add the coefficients, right? So 2 plus 3 is 5, right? So my final answer is 5i square root 3. Exactly. As long as they have the same radical, I can do this. If the radicals were different, then they stay apart. Yeah, that'd be a fine answer. Yeah.
So let's say it was like radical of 4 instead of 3, so it would be 2i radical 3 plus 3i radical 4.
Yeah. If one of the threes was a 4, and I would just leave it like that. Yeah. Say 7. That's better. Because 4 could get broken down into two, yeah. So yeah.
So what if that was the case? Like, what if it wasn't 4? You gotta break it down more?
Exactly. Yeah, I'm gonna let y'all give it a try real quick. Remember, just simplify it down real quick and then just add it. If you can, you add the like terms together, right? If they have the same radical, the same index, all of that. Try that out. Exactly.
And then, but then it's
Two.
two.
Right.
But then
Yeah.
it's 4.
For I. Yeah. All right, y'all want to try this out? All right, let me just get a nice, pretty color. What I'm gonna do, I'm gonna go with this one right here, right? So I want to break down the square root of -8, right? I'm gonna call this square roots for, let me say that again, square root -4, and then square root 2. And the square root of -4 we know is 2i square root 2. I'm gonna break down square root of 32. I'm gonna call that square root -16 times square root of 2. So then that's going to become 4i square root 2. And then now they have the same index, the same radicand. They even got the same I going for them, right? So now I can add them together. 2 plus 4. So 6i square root 2. And that's my final answer. Questions on this? Good? All right, let's keep it moving then. Yeah. Oh no, we got more. Yeah. Nah, real talk, high school is way harder than this. Keep it 100. Yeah. Right. I feel you. I'm right there with you. Like high school was challenging, man. SATs was hard too. That wasn't an easy test either. All right, so let's look at for A, right? So I got 4 minus 3i plus 5 plus 6i, right? Now, because it's addition, I could kind of just drop the parentheses a little bit, right? So I could make this 4 minus 3i plus 5 plus 6i, right? Now, check this out. This is what I want to do, right? Combine like terms, right? Combine like terms. Numbers with numbers, right? Imaginary or complex, whatever with complex, right? So 4 plus 5 is what? 9, right? And then -3i plus 6i is what? So that's plus 3i. And I'm done. That's my answer right here. That's it. You know? Yeah. It was light work, light work. I'm gonna switch it up real quick. Let me get another color. You know what? I'm gonna try the red out. I don't really do red that much, but I'm gonna try it out. All right. So for B, right? So what do I want to do? Right? I want to subtract these. I got 2 minus 5i minus 5 minus 2i, right? Real simple. All you're going to do, take the negative and distribute that. Boom, and then boom. That's it, right? And then becomes an addition problem right after. So I have what? 2 minus 5i, and then a negative times a positive 5 is going to give me a -5. And a negative times a negative is going to give me a positive 2i. Just like that. After that, what I want to do, combine like terms. 2 minus 5 is what? Right? So this is -3, right? Right, done with that. Now, -5i plus 2i is what? -3i. And then that's it. We're done. All right, questions on that?
So you just remove the parentheses for adding and subtraction only, right?
For subtraction, you got to distribute the negative, and then you could combine like terms and add. But Like I multiplied it. So negative times positive 5, you give me a negative 5.
Oh, so
Right? And then a negative times a negative 2i, give me a positive 2i.
it don't stay negative, it don't turn positive.
Right. It like switches the signs basically. Everything to the right, you're switching the sign. And then after that, you just combine like terms and that's it. You know?
Okay, wait, so
Yeah.
let's say you were not doing that, you were doing like solve stuff. Would it be, like we were doing something right, with problem or kind of,
Yeah.
you were, so they're gonna turn to a positive, negative to negative?
Yes. Negative times a negative is a positive. Right. This is actually PEMDAS. This is what I'm doing right now.
Ah.
This is actual PEMDAS. Let me let y'all try this real quick. Then we're gonna take it up a notch real quick. Try that out. Got it? So, all right, let's take a look, right? So I got the 2 plus 7i plus the 4 minus 2i, right? Remember this addition. So with addition, I could just drop the parentheses. So I'm gonna have the 2 plus 7i plus the 4 minus 2i. Just combine like terms. That's all you got to do here. Combine like terms. So the 2 plus 4, let's call that 6. And then the 7i minus the 2i, right? Let's call that a positive 5i. And that's it. That's the whole question. All right. Questions on that, or are we good? Good? All right, let's take a look at another one. I'm gonna look at B. All right, we're gonna go from red to green for Christmas, right? So what you want to do, distribute the negative first, the minus sign, right? In other words, change all the signs of whatever's to the right, and then combine like terms, add. And that's it. Let's try it out. So negative times 2. So I'm gonna have 8 minus 4i, excuse me. Let me just move this. And then a negative times a positive 2 is gonna give me a negative 2. Then I'm gonna do a negative times a negative I, it's going to give me a positive I. Questions on that step? All right after we do that, we're back to where we were at before. We're just going to combine like terms, right? Real numbers are real numbers, complex are complex. 8 minus 2 is what? 6. And negative 4i plus I is what? So negative 3i. And that's it. That's the whole question. That's the one that's confusing, the negative, I mean the minusing.
Yeah,
Yeah. Just distribute it. Just distribute it and then combine like terms. Yeah, only the ones to the right I'm changing. Yeah, and that's it. And then it's just straight up adding, you know? All right, let's take it up a notch. So what I want to do next is I want to multiply complex numbers, right? That's my next goal. So multiplying complex numbers is also much like multiplying expressions with coefficients and variables. So there is only one special case we need to consider, and we'll look at that after we practice the next 2 examples, all right? So let's check this out. let's say I have a question like this, right? I want to multiply 2i times 7 minus 5i, right? So you already know what I'm going to do, right? I'm going to push this up real quick. You already know what I'm going to do, right? I'm going to take the 2i and I'm going to multiply it by the 7. So 2i times 7 is what? What do y'all think it is? 14i. That's excellent. Remember, numbers with numbers, radicals with radicals. That's perfect. All right, here's a hard question now, right? I got a positive 2i times a negative 5i. All right, so negative, right? Because a positive times negative is negative. 2 times 5 is 10, and then we have I squared. That's perfect. No, what does I squared mean? You're right, you're right, you're right. What does that mean? Yes, it means -1. All right. So let me put y'all on game real quick. All right. Now we'd have to simplify it fully, right? So let's recap real quick. Let me change the color real quick. Hold on, let me change the color. Yeah, I'm a color head, man. I'm a color head. All right, real quick. I is the square root of -1. So if I say what is I squared, right? Low key, what am I saying? It's got to be no, it's -1. Because look what's happening, right? I'm taking the square root of -1 and then I'm squaring it. And you know the square root and the square cancel out, which leaves back just -1. Yeah. Without the radical, just plain -1, just whatever's on the inside. All right, let's say I said I cubed. I'll show y'all something. Let's say I said I cubed, right? You know I to the third is just what? I times I to the second, right? That's not so bad, right? So we know what I to the second is. We know that that's -1. So this is just I times -1, right? So this is just negative I. It's that simple. Let's say that I had I to the fourth. I to the fourth. You already know what this is going to be, right? I to the second times I to the second, right? Well, we already know what I to the second is. That's -1, right? So what does that mean? That means that this is -1 times -1, and -1 times -1 is +1. That's it. Yeah. So this is how you do it, right? I'll be honest with you, I don't remember this list, right? You guys can choose to memorize it if you want, right? What I remember is I remember I is equal to the square root of -1. And from that information, I derive everything else, right? So you said I squared was -1, right? So what's going to happen to our question here? This is going to become 14i minus 10 times -1. And a negative times a negative is a positive. So my final answer, let me scroll down a little bit. My final answer is actually 14i plus 10. But let's take this up a notch, right? Remember, we want our answers to be in standard form. Standard form is a plus bi. So the real number plus the complex number. So exactly, you're gonna flip this around. So 10 plus 14i. This is the answer that we're looking for. I'll be honest with you, if you gave me 14i plus 10 on the test, I'm gonna give you the points for that. I'm gonna give you full credit, right? But when y'all go on to math 30, y'all next class and stuff, they want it in the standard form. So that's gonna be the a plus bi form. All right. But I will give you full credit for the 14i plus 10. All right. Yeah, that's it. You guys try. Try it out. No problem, no problem. Let's take a look real quick. All right. Feeling like purple for this one, right? So I have 4i times 5 minus 3i, right? I want to distribute the 4i onto both terms. So 4i times 5 is going to give me a 20i. And then I'm going to do the 4i times a negative 3i. Positive times a negative, we know is a negative. And what is it? Perfect. And we said that I squared was -1. So then this becomes 20i minus 12 times -1. And the negative to negative is a positive. So this is 20i plus 12. I'm gonna put this in standard form because that's what they want in your next class. So this would be what? 12 plus 20i. That's it. And that's the whole question. Questions on that, or that's good? Good. All right, cool, 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 cool. Even though this might go ahead. Yeah. Even though this next question might look a little crazy, we low-key know how to do this already. It's the same thing. Right? We on that binomial jump off. The same thing. All right. I'm gonna switch this one up too, though. Hold up. How am I feeling about this? All right, we're gonna rainbow this one. Right? We're gonna rainbow this one. Right? So go step by step. 3 times 4. What's that? 12. Right? You're just foiling it, right? 3 times -3i is -9. Perfect, perfect, perfect. Now I want to do the inside, right? What's that gonna be? That's 2i times 4. What's that? Right? So plus 8i. Very good. And then last but not least, I have a positive 2i times a negative 3i is gonna give me a 6i squared. That's perfect. That's perfect, right? What was I squared again? I forgot. Negative 1. Good, 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 good. So I have 12 minus 9i plus 8i minus 6 times negative 1. Let's do our multiplication, right? So this becomes 12 minus 9i plus 8i, and negative 6 times negative 1 is positive 6. Now, this next idea, what I want to do, I want to combine like terms, right? Real numbers are real numbers, complex numbers are complex numbers. So help me out. 12 plus 6 is 18. And negative 9i plus 8i is a negative 1i. Good. If you want, you can put the 1 in front. No need to, though. And that's it. That's my final answer in standard form.
What is it?
Yeah.
Because the I is negative 1.
Huh?
Didn't the I count as negative 1?
No.
Oh, is it
Oh, it's the square root of negative 1. Yeah, but we write it as I. Yeah.
What is that negative?
Mhm. No, same thing. All right. Let me let you guys try one. All right, just keeping it simple. Check that out. Good. Not so bad, right? So I'm gonna just go step by step. Go pink with this. So 5 times the negative 1 is what? Negative 5. Perfect. And then now I want to do the 5 times the negative 2i, which is going to give me a 10i. That's perfect. And then now I want to do the negative 3i times the negative 1, which is going to give me a positive 3i. And then last but not least, I want to do the negative 3i times the negative 2i, which is plus 6i squared. And we said I squared was what again? Negative 1, right? So this is minus 5 minus 10i plus 3i plus 6 times the minus 1, right? Let's do our multiplication. We're going to have a negative 5 minus 10i plus 3i minus 6. And then I want to combine like terms, right? Combine like terms. So negative 5 minus 6 is negative 11. Perfect. And then negative 10i plus 3i, what's that? Perfect. Negative 7i. And then that's it. That's my final answer. Questions on this? Good. Awesome. Awesome, awesome, awesome. All right. So next I want to talk to y'all about some tricks. You do not have to follow these tricks if you don't want to. They are optional. I'm going to do the trick in front of you because everybody knows how to FOIL already. But just to recap real quick, I want to multiply 3 plus 2i squared, right? You guys remember when we have our, what do they call these again? The trinomials. Let me get the binomial squares pattern. That's what I'm trying to say, right? You guys remember our binomial squares pattern? Let me just recap real quick, real quick, real quick. I'm gonna do it in green, right? If I have a plus b squared, we remember that that's the same as a squared plus 2ab plus b squared, right? I'm gonna use this same trick in this question right here, right? If you don't remember this, it's okay. Remember what 3 plus 2i squared really is. 3 plus 2i squared is very simply just 3 plus 2i times 3 plus 2i. Repeat it, and then you know what to do after that. You just FOIL it, right? But I'm going to use the trick pattern because that's what we're trying to learn right here. But you don't have to use a trick if you don't want to, right? Completely optional. All right. Anyway, let's get back to this question. All right. I have a 3 plus 2i squared right here. So what's this going to be equal to? This is going to be 3 squared plus 2 times 3 times 2i, right? Plus, open parentheses, 2i squared. Just like that. It's just as simple as that. Let's do the math on that. Let's do the multiplication and stuff, right? So this is going to become 9 plus 2 times 3 is 6. 6 times 2 is 12i. Plus, what's this going to be? 4i squared. And we said I squared was what again? I forgot. -1, right? So this is going to be equal to 9 plus 12i plus 4 times -1. Let's do the multiplication on that real quick. So I'm going to have 9 plus 12i minus 4. Let's combine like terms. 9 minus 4 is what? It's 5. So final answer, 5 plus 12. And that's it. Questions on this? Make sense? Let me let y'all try one. No, no, no. Remember what we did before? When we have the binomial and then we FOIL it? You can do that too. Yeah. This is a trick. I'm just showing you guys a trick. You're welcome to use a trick, or if you want, you just do it the foiling way, right? The foiling way works all the time for every single binomial pattern, right? Or every single what do you call it? Multiplication of binomials, all of them. The foiling will work, right? Or distribution. But this is a trick. You can, whenever you have a repeat situation like this, then you can use this trick if you want to, but you're not required to. All right. At the end of the day, all I care about is the right answer. How you give me the right answer, you guys have options. All right. But this is more for like completion, just to say that I showed you it, you know? I'm gonna let you guys try one real quick and then we gonna move on. Try that out real quick. Try that out real quick.
That gonna become father, right?
Correct. All the time, man. No worries, man. Got you, got you. Well, yeah, just watch the recording. Remember to knock out the homework too when you get a chance.
About over a bunch more things or just one vote?
No, I got more stuff, but it's you know what's missing? Division.
Vision all our.
Yeah, but it's the same. It's low key. It's the same division that we did with the radicals. You know, so yeah.
That's about, you said Monday you gonna be there 12 to 8?
Yeah, all day. Yeah. So you come pick up the test. You know, you can fix that one, and I give you.
3.
Yeah, I got you. I got you.
Good.
Come through. Come through. Yeah.
This class was a little later, probably like 3. I'll probably be here, probably take a nap.
Got you.
But
You mean-
I boarded at 9 until like 1:30, I think.
Got you. Got
So
you.
it's like, I just got back from a 12-hour shift. I take a
Yeah.
couple hours naps. then
Yeah,
I-
they come through. Dang, dang.
And I told him I tried working, but
Yeah.
I gotta keep working. I gotta get money.
I understand. I understand. You don't get GI Bill or anything? You don't get the GI Bill or anything?
What is that?
Like for military, GI?
Oh,
You gotta ask about it though, man.
this is GI.
It's a bill, like they give you money to go to school and stuff. Yeah.
I think it's because I'm flat footed or something, I don't know. Cause I heard you can't get benefits from military if you have like something.
Like if you're dishonorably discharged kind of thing.
I don't even know much about military, I never been to much, but
Yeah.
they sent me some papers from the Navy, like trying to hook me up, I'm not.
You weren't in it?
The Navy?
No, like the military.
No, I'm not in the military.
Oh, for real?
Nah, I just like military clothes though.
No, it's the boots that I'm looking at. That's
Oh,
what that's
the boots?
yeah, yeah.
Yeah,
'Cause I recognize them. Yeah. Yeah. Got you. All right. My fault, my fault. All right. Now anybody can get them pants, but you can't get them shoes. Them shoes is official. Yeah. The military, they have their own version of shoes. Yeah. It's something or it looks like them.
It probably does look like.
Yeah.
Yeah, they're.
Oh no. But they have there's like a special shoe that they have that's like it's like only for them kind of thing, you know? Yeah. I mean, I'm not military, so that's why I can't tell. Yeah. Yeah.
I knew somebody in the military, we was talking about, this honorary.
Discharge, yeah. But when you are discharged honorably, you get like the GI fund and then they give you money to go to school.
Even the home with our,
Yeah.
trying to understand, so
Yeah.
I do 20 years, I was like, you know how they be lying sometimes?
Now there's some people like sad to say, but there's some people like they'll buy like military gear, like clothing and stuff, you know, not like you, like you're like
They just regular khaki bone.
yeah. They just have the pattern, but there's some people that'll buy the official authentic
Oh, like,
joint,
oh,
right? And they ain't never did a day in the military, then they'll act like you know,
Yeah.
yeah, it's messed up. It's messed up. Yeah.
I just like that.
Yeah, it's nice though. It's a nice combination. All right, let's look at this, right? Multiplying using the binomial squares pattern, right? So we have the -2 minus 5i squared. Again, optional, right? I'm doing the square pattern, but if you don't want to do this, you want to do the distributing, be my guest. All right. So real quick, just to recap, it's gonna be a minus b squared, right? And the pattern is a squared minus 2ab plus b squared, right? What's my question? Let me change up the color. My question is -2 minus 5i squared. So what am I gonna have? I'm gonna have -2 squared minus 2 times -2 times the 5, excuse me, times 5i,
That's the formula.
but right, plus the 5i squared. Right? You don't have to follow this formula again. This is completely optional.
You get the same
Right.
answer.
You get the same answer. You know, I'm just doing a shortcut because that's what they asked for, you know, kind of thing. Right? So
That's how we won't have to do it on the test.
it's your choice. You could do this, or you could do the FOIL method, the distributing. Right? Distributing works for every question. Right? This is a special situation for when you have repeats. All right. So -2 squared, that's gonna give me the 4. And then -2 times -2 is +4. +4 times 5 is gonna give me a +20i. And then I'm gonna have what? Plus 5i squared, that's what? 25i squared. And we said I squared was -1, right? This becomes 4 plus 20i plus 25 times -1. Let's do our math on that. So this is gonna become 4 plus 20i minus 25. Let's combine like terms, right? So I should get a what? A -21 plus 20i. And that's my final answer. Questions on this? All right, bet. Let's keep it moving. Go ahead. Go ahead. Look.
Each one is always gonna be a letter plus that.
With the I, yeah, yeah. For this particular topic, yeah.
I'll never get the lettering or the number thing. I never would get
Yeah.
how to do it.
Promise you, it gets easier. It gets easier. All right. So since the square root of a negative number is not a real number, we cannot use the product property of for radicals. In order to multiply square roots of negative numbers, we should first write them as complex numbers using the square root of negative b equal to the square root of bi. This is one place students tend to make errors. So be careful when you see multiplying with negative square root numbers, right? So look, long story short, long story short, right? I'm gonna give you a question, simplify it, and then multiply it. All right? Simplify it and then multiply it. Let's look at one real quick. Look at this. So I got square root of -36 times the square root of -4. Simplify it, then multiply it, right? We already know this is what? This is 6i times 2i. We're good, right? Simplify it. Now multiply it, right? 6 times 2 is going to be 12. I times I squared. And we said I squared was what again? -1, right? So this becomes 12 times -1. Final answer, -12.
So I'm gonna remember it like, don't like, you know, how negative is.
Yeah.
You gotta remember that.
So simplify it, then multiply it. That's how we do it. Simplify it, then multiply it. All right. Any questions on that or it makes sense? All right, you guys try one. Remember, simplify it, then multiply it. All right, let's take a look. So we already know what the square root of 49 is, right? That's 7i, right? Times, we know what the square root of -4 is, 2i, right? Then we're just gonna multiply those together. 7 times 2, I times I, 14i squared. And we remember that I squared is -1, so 14 times -1 is final answer, -14. Questions on this? Good. All right, let's keep it moving. Make a comment real quick. All right, so in our next example, each binomial has a square root of a negative number. Before multiplying each square root of a negative number, right, excuse me, before multiplying, each square root of a negative number must be written as a complex number. Simplify it and multiply it. Let's take a look. So here's what I'm saying, right? I want to FOIL it. I do. But what I'm saying is first simplify it and then multiply it, right? So let's take a look, right? This first one is going to become what? The 3 is going to stay the same, minus square root of negative 12 is going to be what? Square root -4, square root 3. So that's like what? That's 2i square root 3, right? Remember that. And then we have the 5 plus, that's going to stay the same. Square root -27, we know is what? Square root -9 times square root 3. Square root of -9, this is going to be a 3i square root 3, just like that. And then we're right back to where we were before, right? What am I going to do? I'm going to FOIL it. That's it. We're going to FOIL it. I'm going to change up the color, though, real quick, though, all right? Oh, shoot. Hold on 1 second. I'm sorry. I don't know how that happened. Apologize for that. I'm gonna change the color up real quick. Let's go with pink. So 3 times 5, what's that? That's gonna be 15. Then I want 3 times positive 3i square root 3. That's gonna give me a positive 9i square root 3. Now on the inside, I have a negative 2i square root 3 times 5 is gonna give me a negative 10i square root 3. And finally, last but not least, I have a negative 2i square root 3 times a positive 3i square root 3, which is going to give me a negative 6i squared, right? Square root of 9. Whoops, sorry. Let's simplify this and then combine like terms, all of that stuff, right? Because it's a little bit much, right? So we have 15 plus 9i square root 3 minus 10i square root 3, right? -6 times -1, square root of 9, we know is 3. All right, let's do the multiplication on that. I have 15 plus 9i square root 3 minus 10i square root 3. A negative times a negative is a positive. And then 6 times 3, what's that? 18. Now, I just want to combine like terms, which is a fancy way of saying add, right? So 15 plus 18 is what? 33, right? And then 9i square root 3 minus 10i square root 3 is what? Exactly. Negative I square root 3. That's my final answer, and I'm done. Questions on this? Anybody? You good? All right. I know it seems like a bit much, but we getting through it. The lesson here, simplify it, then multiply it. Try that out for me real quick. Yeah, try this out for me. Let's take a look. All right. So simplify it, then multiply it. So this is going to become 4 minus, what's this? 2i square root 3 times 3 minus
Or two
Um,
on seven.
7?
Yeah, cause 8 and 7 can be. No.
Oh, I'm sorry. I thought you meant for the 12. I'm like, what? 48. I feel like it's 16, no? Times 3, no? 32 and then 32 plus 16, 48. Yeah, it does. Yeah, because look, if I have square root negative 16 and then square root 3, what does that become? That becomes 4i square root 3.
I'll put 2 on.
Yeah. So it's okay if you break it, like say you look at 48 and you're like, damn, I see the 4, but I can't see the 16. That's fine. You can break it down and then call it 2i times what is it gonna be? 2i times 24. Right? But we just gotta know that, okay, wait, I could put another 4 out of that, and then boom. Yeah. Yeah, so that's how that works. All right. When we get to this step, we're right back into the foiling thing, right? Just foil it. 4 times 3, that's 12. 4 times negative 4i, that's negative 16i square root 3. Negative 2i square root 3 times 3, that's a negative 6i square root 3. Last but not least, a negative times a negative is a positive. 2 times 4, we know is going to be 8i squared square root of 9, right? Let's simplify this down because that sounds a little complicated. So I have 12 minus 16i square root 3 minus 6i square root 3 plus 8 times negative 1 times 3. Just like that. All right? Let's do the multiplication on this. This is going to become 12 minus 16i square root 3 minus 6i square root 3. A negative times a positive is a negative. 8 times 3 is what? 16, was that 24? Now, yeah, now I want to combine like terms. 12 minus 24. So give me a negative 12. Negative 16i square root 3 minus 6i square root 3. That's going to be a negative 22 I square root 3. And then that's it. Questions? It's not 24? It is 24, right?
It's not 24 after that?
No, no. No, no, 12, because the 12 and the 24 is 20 is negative 12. Yeah. Yeah, 12 minus 24 is negative 12. Yeah. All right, then that's it. Let's keep it moving.
Vision. I mean, you put the vision in there.
We get into that. We're not there yet. We still building up to it. But I got you. We're gonna get to it. All right, real quick. So we first looked at conjugate pairs when we studied polynomials, right? We said that a pair of binomials, we said that a pair of binomials that each have the same term and the same last term, but one is a sum and one is a difference, is called a conjugate pair and is of the form a minus b times a plus b, right? A complex conjugate pair, right? For a complex number of the form a plus bi, its conjugate is a minus bi, right? Notice that we have the same first term, same last term, but one is a sum and one is a difference, right? So y'all see where I'm going with this, right? I just want to say it one more time, just to overemphasize it a little bit, right? So a complex conjugate pair, that's what we're calling this. A complex conjugate pair is of the form a plus bi times a minus bi, all right? Complex conjugate pair, that's what it's called. And then let's take a look, right? This is how to multiply the complex conjugate pair. I'm gonna do a little trick here. If you guys don't like the trick, just do the distribution the way you know how. All right? No problem with that. Right? Here goes the trick. I'm gonna show you guys. If I have A minus B times A plus B, I know that that's gonna be A squared minus B squared, the difference of two perfect squares. Right? I'm gonna do that same trick with this one, right? So I have 3 minus 2i, see you later, times 3 plus 2i. Right? So that's going to be what? That's going to be 3 squared minus the 2i squared, just like that. So you already know what this is going to be, right? This is going to be 9 minus 4i squared. And we said that I squared was what? Negative 1. So this is 4 times negative 1. Negative is positive, so this becomes 9 plus 4. Call that 13, and that's my answer. Questions on that? Does that make sense?
That one,
Yeah, I use the formula right there.
that
If
one.
it's confusing, go back to the distribution, because you already know how to do this. 3 times 3.
Okay.
Yeah, you can foil it. I'm just using tricks here. I'm showing you guys tricks, but y'all know how to do this already. Just foil it if it's not clear. All right. By the way, love your shoes. Very nice. Yeah. I'm gonna let you guys try one. Go ahead, try that out. I guessed it. I just copy whatever is there for A and B. And I square it. And I subtract the two answers from one another. Difference of two perfect squares.
Negative plus a positive is a positive, right?
A negative plus a positive, it depends on the size. So you keep the sign of the larger number.
But they're the same. What if they're the same?
If they're the same, then they have the same sign. Yeah. Like a negative plus a negative is a negative. It's just a bigger number, negative. So like -3 plus -4 is -7. If that makes sense.
I'm talking about negative. Let's see how that's a positive, so which one would be negative, positive, which one would be very,
Or like if you were multiplying them,
yeah.
so it would be -9i squared.
Will be a
Because-
negative.
yeah.
Something negative.
Right. So a negative times a positive is a negative, and 3 times 3, 9, and then I times I squared. Yeah. All right, let's go over this real quick. I'm gonna use a trick though, save time. So A minus B times a plus b. It's gonna be equal to a squared minus b squared. In my case, I have 4 minus 3i times 4 plus 3i is going to be equal to 4 squared minus 3i squared. This is going to be what? 16 minus 9i squared. And we know that I squared is -1. So 16 minus 9 times -1. Let's call that 16 plus 9. What's that? 25? 19, 20, 25? Questions on that? Anybody? Distribution way. All right. So with the distribution way, I'm gonna change the color up though. So with the distribution way, I'm gonna do 4 times 4, which is gonna give me 16. Then I want to do 4 times positive 3i, which is gonna give me a positive 12i. But I'm gonna do a negative 3i times 4, which is gonna give me a negative 12i. Then I'm gonna do a negative 3i times positive 3i, which is gonna give me a negative 9i squared. Right? And then what we going to do the math on that. This is going to be 16 plus 12i minus 12i minus 9 times -1. Let's do the multiplication. 16 plus 12i minus 12i, right, plus 9. Right? When we combine like terms, a 12i and a minus 12i will cancel out. 16 plus 9, 25. And that's it. Either way is fine. I'll accept either way on the test. Okay. Mhm. So from our study of polynomials, we know that the product of conjugates is always of the form a minus b times a plus b is equal to a squared minus b squared. The result is called the difference of squares. Remember that, right? We can multiply a complex conjugate pair using this pattern. All right. I want to show you guys something cool. I'm going to show you guys something cool real quick. You still copying?
Nah, just,
Yeah, okay. So yeah, I'm gonna show you guys something cool. So when we multiply complex conjugates, the product of the last term will always be I squared, which simplifies to -1, right? So check this out. A minus B times A plus, excuse me, A minus BI times A plus BI is going to give me A squared minus BI squared, which becomes A squared minus B squared times I squared. I squared, remember, is -1. So -1 times a negative becomes positive. So a squared plus b squared. So this leads us to the product of complex conjugates pattern. So a minus bi times a plus bi is equal to a squared plus b squared. Right? This is for complex conjugates, right? This is known as the complex conjugates pattern. It's okay if you don't want to take that in. Just do what you know how to do. Distribute it, and you'll always get the right answer. Right? This is a trick that I'm showing you guys, a new trick. Let's elaborate on it a little bit. So the product of complex conjugates, sorry. If A and B are real numbers, then A minus BI times A plus BI is equal to A squared plus B squared. Right? That's the product of complex conjugates. Let's take a look. What I'm telling you is that if I have this product right here, right? A minus 2i times a plus 2i, right? I could use the complex conjugate pattern to answer it. So a minus bi times a plus bi is equal to a squared plus b squared. In our situation, again, completely optional. You don't have to do this if you don't want to. So, 1 second. Okay. Awesome. In our situation, 8 minus 2i times 8 plus 2i is going to be equal to what? It's going to be equal to 8 squared plus 2i squared, which in our case will be 64 plus 4i squared. I'm sorry. I made a boo-boo. Sorry about that. Hold on. I was not supposed to include that I. Okay. Let me just get rid of this I right here. That's it. And then my answer is 68. Sorry about that mistake. All right. You don't take the I with you. All right. It's just the number in front, the B. All right. So 8 squared plus 2 squared, 64 plus 4, which is equal to 68. Questions on this? Make sense? All right. Let me let y'all try one. Absolutely. It's on your formula sheet. You have it already. You need a new one? Killing me. How you need a new one? How you need a new one? All right, I'll get you one. Yeah,
Oh, wait, I think I got it.
yeah. Not only is it on your book bag, you also have it in the announcements. Yeah. Every time I show you guys a new pattern like this, all them patterns are on the formula sheet. Everything. You know? Yeah. Yeah. So I don't really expect y'all to memorize nothing. Y'all have it all. And y'all have y'all calculators, you know? All right. Try out this pattern again. All right. So I have A minus BI times A plus BI is equal to A squared plus B squared. All right. So I have 3 minus 10i times 3 plus 10i is going to be equal to 3 squared plus 10 squared. Let's call that 9. Whoops. Plus 100. Let's call that 109. Questions on that? Good. All right. Now let's get to where we really wanted to get to. All right. Dividing complex numbers. So dividing complex numbers is much like rationalizing a denominator. We want our result to be in standard form with no imaginary numbers in the denominator. So remember when we was doing radicals, right? It's illegal for me to have radicals in my denominator. It's illegal for me to have I in my denominator, right? That's what that's trying to say. So that being said, check this out. So I want to divide these two. I have 4 plus 3i divided by 3 minus 4i. It's illegal for me to have that I in the denominator. So 4 plus 3i over 3 minus 4i. We're going to rationalize the denominator. So what does that mean? I'm going to multiply this by the opposite, by the conjugate. 3 plus 4i, right? Remember, I'm trying to match the bottom, match the denominator. I have 3 minus 4i. I'm going to multiply this by 3 plus 4i. But what I do to the bottom, I do to the top. So this becomes 3 plus 4i. After that, you already know what to do. Distribute, combine like terms, all that good stuff, right? So let's distribute this, combine this. I'm going to get what? 3 times 4, call that 12. 4 times 4, call that 16i. 3 times 3 plus 9i. 3i times 4i plus 12i squared. And on the bottom, remember now, this is complex conjugate right here on the bottom. So you already know what that is, right? That's just very simply 3 squared plus 4 squared. Right? Same thing we just did above. That's what's on the denominator here. All right, let's do some math. Let's combine like terms. Let's do our multiplication, all that good stuff over here. So I'm going to have 12 plus 16i plus 9i plus 12 times negative 1 over the 9 plus the 16 right there. All right, let's do our multiplication. I have 12 plus 16i plus 9i minus 12 over the 9 plus 16. All right, let's combine like terms now. Combine like terms, right? So in the numerator, 12 and 12 will cancel out. 16i plus 9i, let's call that 25i. On the bottom, 9 plus 16, what's that? 25, right? Right, they cancel out. So the final answer is just simply I. And that's it. Questions on this?
Change what, right?
No.
The first step.
The first step, what you're doing is you're rationalizing the denominator. So
Keep changing.
let's not keep changing. Keep change flipping when we have a fraction divided by a fraction. That's coming. We didn't get there yet. Yeah. This is just a standard, like you have a division problem, it's illegal to have the i's in the denominator, so you rationalize the denominator. That's what this is.
So why didn't the odd become I to the second power?
It would if I did it distributing, but what I did was I was using, right, the lesson that we just learned, the complex conjugate pattern. A minus bi times a plus bi is a squared plus b squared. All right. If you're on your test and you forget this, which is okay, even though it's on your formula sheet, right? Just do what you know how to do. Distribute it and then combine like terms. You'll never get it wrong. Distribute it and combine like terms. Promise you that. Hmm? Yeah, yeah. I don't have the information yet, but I'm gonna post it. Yeah, as soon as I promise you, as soon as I know, I got you. As soon as I know. Yeah, every time. Every time, every time. Try that out real quick, yes. Real quick. Yeah. See you. Bye. So guys, I have another topic I need to touch. And I'm looking at the time. I don't have the time on Thursdays to stay a little bit longer. So I'm gonna keep teaching. And if you guys wanna, huh?
Once they are done,
I'm sorry?
another class at 4.
No, that's fine. You can go to your class, right? So what I'm saying is I'm gonna keep teaching. Watch the recording. All right? Yeah.
The recording is gonna be in, I mean,
Yeah, it's gonna be on YouTube. You'll see it. Yeah. I'm gonna, yeah, that's fine. You can go. I got you, I got you, I got you. You need a charge or something? What phone you got? Yeah, what you got?
iPhone.
No, I got the iPhone. You got the cable? Cause you got the cable, I got you. You got the cable? Got
I don't
you.
got extra cable. I got like it's like one of those.
Yeah,
It's
yeah,
all you have to do.
yeah. Got you.
But it's.
Wait, I might got something for you. Hold on.
I watched the video.
Yeah, just watch the video and we'll go over everything else that you didn't see. Have a great night, man. All right? See you. Thanks.
Like, definitely way easier. There's not enough to do.
Yeah. Got you. Let me.
You said something about to do the other test we took, the second test we took.
Oh yeah, so bring it to tutoring and then you can do
No,
the
I
test
didn't get it
corrections.
yet.
Oh, you didn't get it back yet?
No.
My fault. I'm sorry. Oh wait, no, I didn't finish grading it. That's my fault. I'm sorry. My mind is not here. I'm gonna get that to you
Next
by Monday next week. Yeah.
Thank you.
Yeah. Yeah, does this work for you? Yeah, that's it. That's a formula sheet. I don't know, do any of these work for you? Yeah, if they work, I got you. All right, we good. Yeah.
How that work?
So I'm gonna just put it on the computer right here. Yeah.
I was using that as like, cool.
Good.
I was like, regular.
Let me see. You. Wait, come here 1 second. Like, is it charging?
Oh, it's not.
It's not because I'm over here looking up here.
I think it's because it's like, what do you use it? I think it's like it's not a charger, you know?
Got you.
Probably an adapter or something like that.
Got you.
Like so
Got
you
you.
can transfer stuff.
Let me see if I could. I do gotta.
Or maybe it's because it's connected to that. Plug it into the wall.
Yeah.
Yeah, it might work.
You just said it's not long, so I want you to put my Google.
Not good. Pretty good. You can put that in. Here we go.
Cool, 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 cool. This is
I was on man.
I mean, I was but y'all was here before me, so I didn't want to I think y'all set the mood. I didn't want to change it on
I thought it was just, y'all thought it was hold on now. Here on why, I came into the 505.
Yeah, like you can see on, but it's like that high, like you wow, you know? All they need is a little fan and that's it. Gucci with that.
These days, my house.
You see you fire, man.
I'm telling y'all, I think it's the whole house.
I got one at home too, just like that. This one might be more powerful than the one I got. Excuse me 1 second. Sit down for this, or we could keep going with this. And then whenever you ready, you know, no pressure. Just that you know it's the end of the semester and time is running by, you know, so I want to make sure I got everything completed, you know.
I wish I would. I feel like it was better if I didn't work, you know. This is rich, and
I understand. When we finish class, I'll talk to you about scholarships and stuff because there's ways you can do that. Yeah, got you. I mean, I got a solution for that too. I'll share with you.
I feel like I'm very, like,
Yeah,
it's just like, you know,
they don't want you to study.
like, you know, we are going to learn about, nobody really likes it.
Got you.
I could sleep,
Right.
that's why I could sleep. I'm hurting, I'm going to school, I'm like.
It's a lot.
School, but I'm tired.
Yeah. Dang. I got you.
Like, it's more than my family can take loud.
Yeah, that sounds like family right there. That's love. That's love. All right, let's check this out. So I got 2 plus 5i divided by 5 minus 2i, right? Now I'm gonna multiply this by the conjugate, right? In the denominator. So this is gonna be 5 plus 2i. And what I do to the bottom, I gotta do to the top. 5 plus 2i. All right. After that, everything is the same. Distribute, combine like terms, all that good stuff, right? I'm gonna do the top first. 2 times 5 is 10. 2 times positive 2i is gonna give me a positive 4i. 5i times positive 5 is gonna give me a positive 25. Whoops, a positive 25i. And then 5i times 2i is gonna give me a positive 10i squared. All of that will be divided by, right? Remember our pattern that we just learned earlier, right? This is going to be 5 squared plus 2 squared. What happened? Yeah. Then after that, let's just do some simple math, combine like terms, all that good stuff. I'm going to do my squares first. So I have 10 plus 4i plus 25i plus 10 times negative 1, all divided by 25 plus 4. All right, let's do our multiplications now. So I have 10 plus 4i plus 25i minus 10 divided by the 25 plus 4. Let's combine like terms now. Now I'm doing my addition, right?
So for my addition, sorry about that. For my addition, right? 10 and negative 10 gonna cancel out. 4i plus 25y, excuse me, is gonna give me a 29i over 25 plus 4, 29. 29 and 29 will cancel out, leaving back just I as my answer. Which yeah, they do. 4i plus 25i is 29i. No, only with multiplication, not addition. Yeah. So then that's it. You just get the I right here. All right, let's keep it moving. Let's keep it moving. I want to give you guys a little bit of notes real quick before we jump into anything else. So this is how to divide complex numbers right here. So step 1, write both the numerator and the denominator in standard form. Step 2, multiply the numerator and denominator by the complex conjugate of the denominator. Step 3, simplify and write your results in standard form. All right? So that's it. Long story short, simplify, then multiply. Simplify, then multiply. That's how we're doing this. And ironically, I know that it's for division, but we have to clear the denominator. We're not allowed to have radicals in our denominator. We're not allowed to have i's in our denominator. Why? Because remember, I is the square root of -1. All right? So I'm going to divide this out real quick. Same process, right? I have a -3 over 5 plus 2i. I'm going to multiply this by the conjugate, right? So the conjugate is going to be the exact same thing, but instead of the plus, it's going to be a minus. It's going to become 5 minus 2i. And what you do to the bottom, you do to the top. 5 minus 2i. After that, just distribute, right? Just distribute and we're good. -3 times 5, what's that? Negative 15, right? -3 times -2i plus 6i. And on the bottom, you already know we got the complex conjugate pattern. So we got the 5 squared plus the 2 squared. We're going to call that what? -15 plus 6i over the 25 plus 4. We're going to call that 29. So -15 plus 6i over 29. Make sense? All right. I'll let you try one. Nothing hard. Try that out. All right, let's take a look. I have 4 over 1 minus 4i. I want to multiply this by the conjugate, right? So this is the opposite. This is going to be 1 plus 4i. What I do to the bottom, I must do to the top. 1 plus 4i. Now we're going to multiply these together. This is going to be 4 plus 16i. Right? On the bottom, we have the complex conjugate pairs. This is what? 1 squared plus 4 squared Let's call this 4 plus 16i over 5. Excuse me. Woo, 1 plus 16. Yeah, you're right. 17. Sorry about that. Plus 16i over 17. Sorry about that. Yeah, yeah. My fault, my fault, my fault. Oh, what happened to this? Why it disappeared on me? Let me try it again. Here, plus 16i over 17. Sorry about that. Don't know what happened there. I'll try another question. Yeah. All right, this is a little bit different. I have a 5 plus 3i over 4i, right? So watch what I'm gonna do with this, right? I'm gonna rewrite this as 5 plus 3i over 0 plus 4i, right? Because we know that there's a 0 exponent there, right? Hold on. We know that there's a 0 coefficient number there, right? Once I do it like that, you already know what's going to happen, right? I'm going to multiply this by the conjugate. So what's the conjugate over here? That's going to be the 0 minus 4i. What you do to the bottom, you do to the top. 0 minus 4i. Right? After that, just distribute, and that's it. 5 times 0. Exactly. And then 5 times negative 4i is a negative 20i. And then 3i times 0 is 0. And then 3i times negative 4i is negative 12i squared. On the bottom, what are we going to have? We're going to have the 0 squared plus the 4 squared. Combining like terms, what do we have? We're going to have the right. So I have negative 20i. Oh, wait. Yeah, I'm going to do that. Minus 12 times negative 1 over the 0 plus 16. All right. Let's do the multiplication. Negative 20i. Go ahead. Wait. 4 and a 12.
What is that? What is it, third power?
Second. My fault. My fault. Let me write that. 4 to the second. 16. Yeah, 16. All right. So then now we got the simplification here. Let's reduce this and flip this around. So this becomes 12 over 16 minus 20i over 16. Let's reduce this. This is going to become, all right, to pull out 4 out of that, this is like 3 over 4. But pull out 4 out of that, let's call that 5 over 4. And that's that. So 3 over 4 minus 5i over 4. A little bit complicated, but not impossible. The lesson here, the denominator, right? Rewrite it as 0, whatever I.
Make sure that 2 numbers at the bottom.
Yeah. Time 4:57. I mean, winter time, you know. But if you have to go, I understand. Yeah.
Oh, I didn't know, I got, 7 million. I got,
I got you. Yeah, get your charge on. I want you to know how to get home, you know. I'm doing the same thing too. Yeah, yeah, yeah. The BCC got a shuttle though. You know, if you want, you can attempt to catch it. It's every 30 minutes. We got a 5 p.m. one. It's gonna be a 5:30. If you want to catch a 5:30, yeah, it takes you to Fordham. You can catch the bus at Fordham, the 12 or the 3 bus. The no, the BCC shuttle is in front of Meister Hall. It takes you to the train. It's a bus on campus. It'll take you to the train if you want. No, 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 it's free. It's free. Yeah, yeah. The BCC shuttle. Yeah, and then they take you over to Fordham, and then you can catch a 12 bus there or the 3 bus, the 17 bus. Oh, by like Southern Boulevard. Yeah, all right, got you. So what you do, you could take the shuttle to Fordham and like Jerome, where the 4 train is, and then you could just take like the 12 bus down to yeah, then that's it. Yeah. You could do that too. Yeah, that's a good idea too. All right, let's take a look at this, right? So I got the 3 plus 3i, right? But on the bottom, I'm gonna make this 0 plus 2i, just like that. And then I want to multiply that by the conjugate. So multiply this by 0 minus 2i. But what I do to the bottom, what I do to the top, 0 minus 2i. Distribute. 3 times 0 is 0. 3 times negative 2i is a negative 6i. 3i times 0 is 0. 3i times negative 2i minus 6i squared. All divided by 0 times 0 is 0. 0 times negative 2i is going to give me another 0. 2i times 0 is 0. 2i times negative 2i is going to give me a negative 4i squared. Right? Let's do them I squares real quick. I have negative 6i minus 6 times negative 1 over negative 4 times the negative 1. Multiply it out. I have negative 6i plus 6 over positive 4. Rewrite this. I'm going to have 6 over 4 minus 6i over 4. Reduce this. I'm going to have 3 over 2 minus 3 over 2i. There you go. That's my answer. Question on that? Because it's times 0. All them other, and 0, is nothing. Yeah. So that's that. Let's talk about something that we were talking about earlier in class, but we're going to elaborate on it a little bit more. So we want to simplify powers of I, right? So the powers of I make an interesting pattern that will help us to simplify higher powers of I, right? Let's evaluate the powers of I. All right, so of I to see the pattern. So I to the first power is equal to I. I squared, remember, reason it's negative 1. I cubed is just I squared times I, which becomes negative I. I to the 4th is just I squared times I squared, which becomes negative 1 times negative 1, which is just positive 1. This is a pattern that continues to repeat itself. I to the 5th is the same as I to the 1, which is I. I to the 6th is the same as I to the 2nd, which is negative 1. I to the 3rd is the same as I to the 7th, which is negative I. And I to the 8th is the same as I to the 4th, which is positive 1. This pattern repeats itself again and again and again in 4s, right? In 4s. This is, yeah. Once you know the first 4, you know the rest, right? So real quick, just want to summarize this again. Let's summarize this. I to the first is equal to I. I squared is equal to -1. I cubed is equal to -I to the fourth is equal to 1. I to the fifth is equal to I to the sixth is equal to -1. I to the seventh is equal to I to the eighth is equal to 1. The pattern just keeps repeating, keeps repeating, keeps repeating. Let's talk about this. So if we continue, the pattern would keep repeating in blocks of 4, right? We can use this pattern to help us simplify powers of I. Since I to the fourth power is equal to 1, we rewrite each power I to the n as a product using I to the fourth to a power and another power of I. We rewrite it in the form I to the n, which is equal to I to the fourth raised to the q power times I to the r, where the exponent, right, q, is the quotient of n divided by 4, and the exponent of r is the remainder of this division. So for example, I to the 57th power, right? You take the 57 and divide by 4, and we get 14. The remainder is 1, right? So in other words, 57 is equal to 4 times 14 plus 1. So I to the 57 is 1. What happened? No, positive 1, positive 1. Right? So it would be 1 to the fourth power, which is then raised to the 14th power times I to the first, which is just I as our answer. So this is what we getting into, right? I'm gonna give you I raised to some number, right? And you gonna do the long division, whatever, and you're gonna give me back the answer. I'm giving you an example. I got you. I'm gonna show you real quick. It's not that bad, man. Say they ask me to simplify what is I to the 86th power, right? All you're gonna do is divide it by 4. Divide it by 4. So what do I want to know? I want to know what is 86 divided by 4, which means 4 that goes into 86, right? So 4 goes into 8, what? 2 times? 2 times 4 is 8. That's 0, bring down to 6. 4 goes into 6 1 time. 1 times 4 is 4. And then, hold on. Four goes into 6 1 time. 1 times 4 is 4. That's 2. And then now we have what? 4 goes into 86 21 times with a remainder of 2. So what does that mean? I to the 86th power is equal to 1, which is I to the fourth, right? Raised to the 21 power plus I to the second power, just like that, right? So long story short, this whole thing is 1. So I to the 86 is the same as I to the second power, which is just what? Square root -1 squared, which we call what? I. Excuse me, -1. Questions on this or it makes sense? My fault, my fault. Got you. So yeah, the next shuttle, it leaves in front of Meister at 5:30. It's 5:07 right now. So if you wanna like go chill in front of Meister until it comes, you can. Yeah, it's coming at 5:30. Got you. Are you gonna take a 3 bus to BJ's? Yeah, you could do that too. Remember, this bus take you to the 3 bus too, the shuttle. It's gonna take you to the 3 bus on University. Right there. It takes you right there. You know that stop where everybody gets off and you actually get a seat? That stop. All right, so we trying out another one, I to the 75th power. So what we gonna do? We gonna do 75 divided by 4. Which is gonna be 4 into 75. 4 goes into 7 one time. 1 times 4 is 4. Call that 5, bring down 5. 4 goes into 55. 20, not 25 times. It goes in 6 times, right? No. $14, I believe. Hold up. I'm a cheat. 75 divided by 4 is giving me what? 18.75. All right. So this goes in 18 times. And then 4 times 18, just having a brain fart, is 72. Software is freezing. All right, so we're going to say minus 72. Remainder is 3. So what does that mean? That means I-75 is just 1 to the 4th power raised to the 18th power times I to the 3rd power. Final answer, I to the 3rd power. And I to the 3rd power we know is what? I to the 2nd times I. Call that -1 times I. Final answer, -I. And that's it. Makes sense, right? I got you, man. A little bit of practice and you'll be good to go. Yeah. And that's our complex number system. All right, I want to start another topic real quick. We're going to have a homework on this, so I figure this will be good to just go through real quick just to help you with your homework, right? So here we go. So a quadratic equation is an equation of the form ax squared plus bx plus c is equal to 0, where a does not equal 0. Quadratic equations differ from linear equations by including a quadratic term with the variable raised to the 2nd power of the form ax squared. We use different methods to solve quadratic equations than linear equations because just adding, subtracting, multiplying, and dividing terms will not isolate the variable. We have seen that some quadratic equations can be solved by factoring, and in this chapter, we're going to learn 3 other methods to use for the quadratic equation to be factored. So let's learn the first method. So our first method is, right, we want to solve quadratic equations of the form right? So we're going to solve quadratic equations of the form ax squared is equal to k using the square root property. We have already solved some quadratic equations by factoring. Let's review how we factored. Let's review how we use factoring to solve the quadratic equation x squared minus equals 9. So if x squared equals 9, we subtracted 9 from both sides to get x squared minus 9. We factored x squared minus 9 into x minus 3x plus 3. Then we use the zero product property to set both x minus 3 and x minus 3, x plus 3 equal to 0. And then we just solve for x. Sorry about that. Then we just solve for x, and then that's it. X equals 3, x equals negative 3. We're going to do the same thing without having to go through that whole process. All right, so here we go. No problem. No problem. No problem. So we can easily use factoring to find the solutions of similar equations like x squared is equal to 16 and x squared is equal to 25, because 16 and 25 are perfect squares. In each case, we get two solutions. X equals 4, x equals negative 4, x equals 5, and x equals negative 5. But what happens when we have an equation like x squared is equal to 7? Since 7 is not a perfect square, we cannot solve the equation by factoring. Previously, we learned that since 169 is a square of 13, we can also say that 13 is a square root of 169. Also, negative 13 squared is equal to 169. So negative 13 is also a square root of 169. Therefore, right, both 13 and negative 13 are square roots of 169. So every positive number has two square roots, one positive and one negative. We earlier defined the square root of a number in this way. If n squared is equal to m, then n is the square root of m. Since these equations are all of the form x squared is equal to k, the square root definition tells us the solutions are the two square roots of k, which leads us to the square roots property. Let's look at the square root property real quick. All right, let's look at the square root property real quick. So the square root property, if x squared is equal to k, then x is equal to the square root of k, or x is equal to negative the square root of k, or x is equal to plus or minus the square root of k, right? Long story short, that's all I'm saying. All right, notice that the square root property gives two solutions to an equation of the form x squared is equal to k, the principal square root of k and its opposite. We could also write the solutions as x is equal to plus or minus the square root of k. We read this as x equals positive or negative the square root of k. Now we will solve the equation x squared is equal to 9 again, this time using the square root property. So watch this. This is going to be fun right here. And less steps. So if I have x squared is equal to 9, what am I going to do? I'm going to square root both sides. And when I square root both sides, I'm going to get x is equal to plus or minus the square root of 9, or x is equal to plus or minus 3. And we have two answers, x is equal to 3 and x is equal to negative 3. And that's it. Right, two different answers for that. So we're kind of simplifying something that we used to do in the past. So now, what happens when the constant is not a perfect square? Let's use the square root property to solve the equation x squared is equal to 7, right? Real simple and nice, right? Here we go. So we have x squared is equal to 9, and then use the square root property. We're going to have x equal to negative 7 and x equal to positive square root 7. So x is equal to square root 7 and x is equal to negative square root 7. You just square root both sides and that's it. I want to look at an example real quick. All right. How to solve a quadratic equation of the form ax squared equals k using the square root property. So I have x squared minus 50 is equal to 0. What am I going to do? Add 50 to both sides. So now you have x squared is equal to 50. Square roots, both of them, right? To get rid of the square. Final answer, x is equal to plus or minus. This is going to be the square root of 25 times 2. Let's simplify that down. This is plus or minus 5 square root 2. And there you go. So I have what? I have two answers here. I have one answer, x is equal to negative 5 square root 2. And another answer, x is equal to positive 5 square root 2. All right. Question on that, or it made sense? All right. So long story short, isolate the x squared, solve for it. All right. Exactly, and then solve it. So let me give you some instructions real quick. All right. So how to solve a quadratic equation using the square root property. Step 1, isolate the quadratic term and make its coefficient 1. So if there's a number that's in front, you're going to divide by that number until you get the coefficient, the number in front of x squared to be 1. Step 2, use the square root property on both sides, so square root both sides. Step 3, simplify the radicals. And then step 4 is to check your solutions, right? Let me show you an example of what I'm talking about. So I have this question here, right? It's 3z squared is equal to 108. I want the number in front of the z squared to be 1, so I'm going to divide this by 3 first. But what I do to one side of the equation, I must do to the other side of the equation. So now 108 divided by 3, what's that? Let's see. That's 36. So I have z squared is equal to 36. Now square root both sides to get z by itself. So I'm going to square root the z squared, square root the 36. And I'm going to get what? Z is equal to plus or minus 6. Or you can tell me z1 is equal to negative 6 and z2 is equal to positive 6. Either answer, I give you full credit for. And that's it. If this is web work, remember to separate your answers by a comma. Right? You're just going to separate it by a comma and you'll be good. All right. So the square root property So the square root property states that if x squared is equal to k, what happens if k is less than 0? Right? Let's take a look at that. What if k is less than 0? Not as complicated as you might think. It's something that you already know how to do. So let's say I had x squared plus 72 is equal to 0. I'm going to subtract 72 from over here. But what I do to one side, I got to do to the other. So now what do I have? X squared is equal to negative 72. I'm going to square root both sides, get x by itself. So it's going to be x is equal to plus or minus, right? And then 72, what's that? Well, square root negative 36 times square root 2, right? And then simplify that down. This is going to be x is equal to plus or minus 6i square root 2. And that's it. So you can give me that answer, or you could give me x is equal to 6i square root 2 and x2 is negative 6i square root 2. That's it.
Same thing.
Yeah, same thing, man. Same thing.
It's very powerful.
X with the lowercase 2.
Yeah.
So it's a label. It's like saying the first X is that and the second X is that. Yeah. The bus? It's a little white bus and it says Bronx Community College on it. Yeah, you got like 7 minutes if you want to catch it. It's at Meister Hall. Yeah, the front of Meister. Yeah. All right, man. You're welcome, man. All right, that's pretty much it though. To tell you the truth, for these types of questions, I'm probably just gonna do one more question that's a little bit more involved, right? So let's say I have a situation like this, right? Where I want to solve the quadratic equation of the form a minus h squared is equal to k using the square root property. We can use the square root property to solve an equation of the form a times x minus h squared is equal to k as well. Notice that the quadratic term x in the original has the form ax squared equals a k is replaced with x minus h. So ax squared equals k is just a times x minus h squared equals k. The first step, like before, is to isolate the term that has the variable squared. In this case, a binomial is being squared. Once the binomial is isolated, right, by dividing each side by the coefficient of a, then the square root property can be used on x minus a squared. Let's take a look. So I want to solve this. Sorry. So I have 4 times y minus 7 squared is equal to 48, right? So what am I going to do here? I'm going to divide by 4 on both sides, right? To isolate the quadratic term, right? That's the y minus 7 squared. Sorry, I don't know why this is happening. I'm going to divide by 4. What I do to one side, I do to the other, right? So now I have the y minus 7 squared is equal to, what's that, 12. Now I want to get rid of the square term, so I'm going to square root both sides because I've isolated it. Now I have just the y minus 7 is equal to what? Plus or minus square root 4 times square root 3. Let's simplify that down. So I have y minus 7 is equal to plus or minus 2 square root 3. Then we're going to add 7 to both sides. So we do to one side, do to the other. Final answer, I have y is equal to 7 plus or minus 2 square root 3. Now we can also rewrite this as y1 is equal to 7 minus 2 square root 3, and y2 is equal to 7 plus 2 square root 3. Either answer you give me, I give you full credit for. All right? And that's about it. That's the most complicated question that we will have for homework, right? Special note that I can tell you. Remember, right? When we take the square root of a fraction, we take the square root of the numerator and the denominator separately, right? So let's keep that in mind, everybody. All right? And then also remember, we want to isolate our binomials. Sometimes our answers will be complex. So we gotta remember that as well. I'm gonna do one last example. This is kind of putting everything together for us, and then you guys should be good with your homework. I don't believe on the homework we have anything as complicated as this question, but I'm gonna go through it and I'm gonna show you. So I want to solve 2 times x minus 2 squared plus 3 is equal to 57. Step 1. I'm going to subtract 3 from over here. What I do to one side, I must do to the other. So now what do I have? I have 2 times x minus 2 squared is equal to, what's that? 54. After that, I want to divide by 2, isolate the square term. What you do to one side, you do to the other. So now what do I have? Now what do I have? I have x minus 2 squared is equal to, what's that? 25, 26, 27. Then we want to square root both sides to get rid of the square. So this becomes what? X minus 2 is equal to plus or minus square root 9 times square root 3, right? Let's simplify that. So now I'm going to have x minus 2 is equal to plus or minus 3 square root 3. Then I'm going to add 2 over here. Where I do to one side, I do to the other. So now I have x is equal to 2 plus or minus 3 square root 3. Now you can leave it your answer like that, and I'll accept it, give you full credit, or you can write x1 is equal to 2 minus 3 square root 3, and x2 is equal to 2 plus 3 square root 3. Either one will work for you. All right? That's it. Have a happy Thanksgiving, everybody. All right. When we come back, we're gonna do some more work together. I believe the week that we return is pantry week. So you guys will need to sign up for pantry if you haven't done so already. And that's it. Have a happy holiday. All right. Catch up with you guys soon.